Good afternoon. Thank you for joining today. So my name is Julien Anguenot, and I will be telling you about Iland, and I'll let you know about the company a little bit after. But basically, we are putting Cassandra into action in a multi-data center deployment, and I'd like to show you a little bit and tell you a little bit about it. So we will start by checking a little bit what we do and the story behind the use of Cassandra, because I think it's pretty important that you understand why we actually choose Cassandra and what we're doing with it. Then we'll take a look at the data and all the constraints that we're having around those use of the data as a cloud provider. And we'll be focusing mostly on the analytics data in that part. Then we'll take a look at our deployment, the configuration, give you some hardware consideration, and an architecture overview of the whole application in a multi-data center deployment. Then we'll take a look at a couple of lessons learned around configuring Cassandra, the problem we've had, the little things that we found were very important, and then some future platform extensions, namely Spark and Kafka, and you'll see why it makes sense for us to actually get there at this point. So let me start by telling you a little bit more about Iland Cloud, because you probably don't know us. You guys probably use Azure or on-premises, AWS, so we're a cloud provider. And what we do is public cloud and private cloud. We are well known for our disaster recovery as a service offering. And we are Cisco certified. We're a VMware partner for about 7 years, and we've been 20 years in business, headquartered in Houston, Texas. So why would you actually host with us and not with Azure? You heard the speech this morning. Well, so we're much smaller. So the big reason why you would want to us is because if you're looking for a custom SLA, because you're not like one of the top 20 biggest company in the world, we can provide like custom SLA. We have compliant data center, so we can help you being compliant, and we give you guarantee on your actual data and all the process around it. We have a global data center footprint. We're in the US. We have 3 data centers in the US, 2 in the UK, and 1 in Asia. And another thing is our platform and our web console management, which is the reason why I'm here, is because I'm going to show you like how it's powered, and of course Cassandra is powering that. So let's take a look at the platform. What have we been building at Iland? So ultimately, this is a data warehousing platform that does both all the collection of data, storing of data, but as well expose API so that we can leverage this data for querying purpose or reporting purpose. So both at the API level or, as you will see, from a client application. We do basically billing correlation, so you'll be able to see like real-time billing, matching your usage, and some predictive analytics that will tell you, for instance, that the 15th of the month or at the end of the month, you will be your cloud will cost you like X amount of dollars. So the web console, let's take a look at it. I think it's going to speak for itself. So you will find here a pretty traditional web management console for the cloud. The thing that you will see here that are like not very common is the real-time billing that you can actually access on your VMs. You have real-time performances and historical performances. So we do from 20 seconds interval on your VM up to 1 year for now. You got the same for the network. You can track your network usage. Billing usage in general with some prediction on the current months going with some details. We provide some full text search. So you can search for VM names, VM descriptions. You can search for firewall rules, port, etc. that you've been configuring. You have alerts, and that's a big deal. So you can actually be alerted when your VM is using more resources than you expected, or if it's costing you more money than you were anticipating initially. Plus other type of alerts, but that would be the main ones. Then you have all kind of reporting available. You can get even history around your environment. We're doing like vulnerability scanning, anti-malware scanning, all kind of different cool stuff, and you are able to actually pull reports that will help you undergo your potential compliance certifications or compliance audit. Then you have alerts. Like typically, this is one feature that I've seen announced by Google Platform last week, is the actual ability to set some threshold and get alerted on the amount of money you're spending on your cloud on a particular period of time. We have, of course, alerts on CPU, memory balloon, etc. All the commands. I'll show you that a little bit later. And you may be wondering, so why did we build all that, right? Well, so we were one of this, a member of this cloud provider using VMware vCloud Director, and vCloud Director also working great. It has some limitation. For instance, the performance analytics, this is something that you will not find inside that software. Typically, this is something that you have when you use vSphere or in-premises deployment. You already have access to all that, but for a public cloud provider, it wasn't the case, at least when we started that in 2013. Then you have all the billing, corresponding like billing and chargeback, matching your environment. And of course, the cross-data center visibility, where if you're deployed in 3 different zones, you want to have like an overview from one central place of everything that's happening in your cloud. And obviously, the idea was to abstract ourselves from the vendors and be able to provide a central platform to access everything everywhere and stitch together several services as part of our offering. So let's take a look at the data for the analytics part. So we'll start with the constraints. So what were the constraints here? So the constraints were basically write latency in a high latency environment, basically multi-data centers. So think about hundreds, thousands, tens of thousands of VM like running. And the particularity is that we are not forcing our customer to install agent. We basically have to pull the information and write it and make sure that it comes in real time and it gets aggregated, etc. So we'll talk about that. It has to be available and the throughput is pretty high, especially when you see the amount of data points and the performance counters we're collecting on a per VM basis. So that was basically the initial constraints for the analytics part. So what we do with those data? We basically collect the real-time data on the VM, and again, no agent. We do that transparently without performance cost for the customer or any hassle with an agent to be installed. We store them, we aggregate them, and then we correlate them, meaning that Cassandra not only have this analytics data, but it has your configuration, it has the tasks that you've been pushing on your environment, it has configuration, user, permissions, everything in there. Then we have to roll up, because when you have the real-time data, you will want to see, on a yearly basis, what's the trend. So we have a 1 minute, 1 hour, 1 week, 1 month roll-ups that are happening. I'll explain a little bit more about that. And then the important part is the processing. The processing is about basically getting alerted when something's going on that's user-defined, and actually have some real-time feedback on what your cost is costing you, your cloud is costing you. And then the reporting and the querying. So let's take a look at those real-time performance samples. So there's 20 seconds interval. This is the smallest we can get from the underlying management software, which is VMware vSphere. This is the smallest we can get. So we have 3 data points per counter per minute. We collect that for all the compute, storage, and network PCs of our cloud. And we have around 15 performance conster on a per VM basis. So it's around 50 data points per minute for a particular VM. They're basically time series, very simple stuff. I'll show you the actual Cassandra table after that. And they have we have a couple of metadata, the unit, the interval, etc. Those, the real-time one, we keep them for a year. So on a 1 year period of time, you're able to get 20 seconds interval performances on your infrastructure on our cloud. So let's take a look just quickly at what are these actual perf samples. So if you check, they're identified by three different values. So you got the group, that will be CPU, memory, disk or network. Then you have the name of it, that will be the usage, like percentage, the CPU ready, usage megahertz, and then the type of rollup that they're doing on their end. So average, summation, latest, etc. So I put on the slide like the actual full list of counters we're getting on a VM on a per VM basis. If you want to see after this talk, you can get the slide online and see for yourself. We have like more counters, but I'm not going to get into that, that are coming from third-party services. Typically, disaster recovery solutions. You will want to see like how like the performances of those third-party services are doing, etc. So we have more than that. So then let's take a look at the time series. So if you take a look at the way it's in Cassandra, it's really the simplest stuff you can imagine. You have a primary key which contains a serial UID, as well as a timestamp, and a value associated with it. What we do then is that we're binding the actual serial UID. It's very simple. It's managed at the application level. We can identify the actual serial by constructing the UID based on the actual performance sample information that I showed you previously. And the serial itself is very easy. You have a new UID that you can match with the actual performance samples, and a primary key that's constructed with the UID and then these 3 values for the counter. So all that to say that this is really easy. This is something that Cassandra does really well, very performant, and at the application level, it's really great to work with it. So if that was only what we're doing, that would be really really not something simple. But this is something that Cassandra does well for us. So there's not really any big challenges around that. Now the difference in our billing model is that we don't price our customer on a per instance basis. We price on a per resource pool basis, meaning that you don't buy 1 VM, 2 VM, 3 VM, and you're invoiced against that. You're gonna buy 100 GB of RAM, 20 GHz CPU, and 2 TB of storage, for instance. And then with that resource pool, you can create how many VMs you have that your resource pool can accommodate. So if we take a look on the left, you have basically like a kind of hierarchy. And at the top level is basically your environment. Then you have the resource pool that you have. Let's say it has, again, a certain amount of RAM, CPU, and storage. Below that, you have a group that in VMware they call VApp. It's see that as a kind of folder that contains VM and that has particular type of property. One of those properties would be some particular network configuration. But I'm not going to get into details into that, but basically it's a group of VMs with properties. And then you have the VM, which means that when you want to provide like real-time analytics on this, you not only have to collect at the VM level, but you have to aggregate on real-time at the VApp level and at the VDC level, right? And this is basically the little challenge with that, is that you have to go through those steps of aggregation before even thinking about doing historical rollups. And all that, of course, is separated tables. It's basically following the same model as you saw before, but just you need this operation to actually aggregate the data. So the historical rollup, I mentioned them earlier. Those, we keep them a little bit longer, especially the 1 hour samples, because they're used for the billing and they're actually necessary for compliance reasons. So usually we keep them between 3 or 4 years. Right, so all that is at the application level. So the 1 minute rollup, as you can imagine, this is how we are able to alert on a 1 minute interval if something goes wrong with your infrastructure, or if you're using too much on something that you've been defining basically, or that we are detecting is actually going wrong in your infrastructure. And this is all real time. And the 1 hour rollups, they are basically used for final billing computation, and this is what we use to charge back the customer. And it's basically using Salesforce, so there's a challenge here where we have to actually always sync up the latest contract information in Salesforce that are basically moving. Because again, remember, we have a custom SLAs. So we don't have one single customer having the same rate on a particular VM. So that adds a little bit in complexity. So now if we talk a little bit about the data sources, so we have, as I said, the compute storage network, but Cassandra here in that case, we don't store only that. We store everything. We store the configuration, the user, the permissions, the third-party services data for backups, disaster recovery, and the platform is basically designed so that you can extend it with extend and remove like services. So as I said, Cassandra is basically the sole record keeper here, and is working really well. And I'm going to show you a little bit more how we're actually putting it in action with other technologies. So our best foundation for our cloud is Cisco UCS, 100% with ESXi, and vSphere for the management layer. So here you have to understand is that not only that is powering our Cassandra cluster and the application I'm talking to you guys about today, but it's actually powering our whole public cloud infrastructure. This is the exact same foundation. So this is how it's looking like on a per data center basis. So we got the actual client, which is an AngularJS client, right, using like API of the warehouse. We have a DMZ with a combination of H3 proxy, KeepAliveD, Apache, initially, taking those requests. We use a fantastic product called Keycloak that's running in a Wildfire application server that allows us to do OAuth 2 and managing our authentication and authorization. And you will see on the right, I actually put it, we have a Postgres database here. This is the last SQL database that we're having on that infrastructure. So then after, we have a layer, a web application server layer, which is providing like REST APIs. And then this is where the action's happening. We have a big JBoss Wildfire IS like cluster. And of course, like, I mean, you know, people are going to tell me that this is way less sexy than Spark or something, but like you have to understand this is a huge cluster. Like if we take the size of this cluster, it's probably as large as the actual Apache deployment in terms of heap size and memory, CPU, etc. Because it does all the roll-up, etc. And I'll be talking about it because this is central in the evolution that we're considering right now. That's basically the spot that will undergo some changes. You'll see as well something is Redis, and I'll talk a little bit about Redis after, on top of using along with Cassandra. Then we have Apache Lucene for the actual full text search. If we have NFS, nothing crazy here. And then we have like Cassandra acting as a foundation. As Billy said this morning, this is really the big foundation for all the application, and this is the one actually replicating over to our data centers. So I'll tell you more about data center, but we got 6, and Cassandra really is the one responsible for that strong acting as a strong foundation, synchronizing data all over the place. So there on the right, it's our actual public cloud. So it's remember it's Cisco UCS, it's VMware ESXi, vSphere, vShield Manager, etc. So it's lots of VMware technologies. And what we have is basically this Wildfire cluster actually pulling, as I said earlier, no agent, we're pulling information from the actual cloud. But as well, we're getting information. So we have an AMQP, RabbitMQ like running here. And that's not for analytics, it's just for events, like knowing what's happening on the cloud, you know, new user created, new VM, change of VMs, etc. And then syslog-ng, we use it for network traffic. We're actually able to route through syslog-ng, DNAMQP, network traffic for further analysis. And I'll be talking about that a little bit after in one of the reasons why we need to extend this infrastructure. Yep, that would be it, I think, for that. So let's get to Cassandra, because I think this is why we're all here. So we started actually in early 2013 with Cassandra 1.2 and Astaniax. I totally remember like doing the prototype as if it was yesterday. I hated the experience using Swift and Astaniax. Honestly, it was really, I remember like having fun like writing it, but I remember like checking the results after like benchmarking for a certain amount of time, and that was totally amazing. So we actually choose to go with that. And in late 2013, the 2.0 arrived with SQL 3. And then we went actually live with a V1 on 2.0, beta 2, I think, something like that. Still with Astaniax, but using SQL 3, which was added at the time in Astaniax. We started with an empty cluster. No legacy data, nothing to migrate, nothing to worry about here. Early 2014, we switched to the Java SQL driver. Big improvement as far as like performance was concerned, and actually network usage and requests. That was really a fantastic upgrade. And late 2014, I remember like being here last year and getting all excited about 2.1. And I'll tell you, we've been like jumping on 2.1, especially for the actual UDT. So I'll let you know about that. So now let's take a look at some numbers for our cluster. So we have 6 data centers. We have only 1 key space right now. Around 27, that's going to vary between 25 to 30 nodes. On a per node basis, it's 1.5 to 2 terabytes, depending on the TTL and depending if we're doing some kind of purging of some data that we consider are not like really critical. I guess that speaks for itself. Basically have those Cassandra those Cassandra racks that are running in the different data center and getting sync out all over the place. On a per data center basis, we have 1 or 2 Cassandra rack of 3 Cassandra nodes. And I'll explain why we have 2 sometimes. We're using the rack inferring snitch for it. We have a virtual private network addressing across the data center. And we use a replication factor of 3, which means like the full data set is actually on every single node, because we still can do it and perform well right now, even when we went to a 2.5 terabyte to 3 terabyte at a time. Nothing crazy. It's a rack inferring snitch. You'll see like the private addressing on the left, data center identified by the second octet. So pretty classic here. And let's talk about the nodes. So each node, first is VM, right? The same way we're in 2015, right? The same way you don't run an Oracle to do that. Well, there shouldn't be any reason for anybody to run like on a bare metal if you can do it on VMs, right? So we're using Ubuntu, we're using the open source Cassandra distribution. 32 gig of RAM per node, 16 vCPU, and we have 3 disks, 1 for the system, 1 for commit logs, and 1 for data. Again, pretty classic setup. For the hardware, we're using some Cisco UCS again, and the disk, it's been fairly interesting to actually see the disk perform. So I will just say that we've been running on 10K SAS for a good, I'd say 1 year, 1 year and a half, 2 years, and we've been able to achieve some pretty decent performances up to a certain point. And that up to a certain point, I think we reached it when we went over like 1.5 terabytes. We started actually using hybrid arrays in some of the data center that were the most busy. But honestly, we are still having actually 10K SAS these days. We are basically switching gradually to hybrid accelerated SSD, but it's working pretty well. So when it's not working well, it's when you actually are booting a node, when you need to perform like operation, or when you need to stream. So that usually doesn't really work well. But Cassandra, what it needs is CPU and RAM. It's all you can eat of that. You can give CPU and RAM to Cassandra, it's going to eat everything. What we see as well is that the writes are actually super well handled in Cassandra, and we see that even if you have a high write throughput, you'll see like some a very low percentages of write on those nodes because it's probably handled. I mean, at this level, on the IOPS, at the IOPS level, we see a lot more read than writes at this level. So it's working quite great. Network-wise, we've been running with 1 gig line for almost 2 years. We're switching basically like currently on 10 gig lines. So it's very chatty, Cassandra. You have the default throttle, which is the one we're using right now. If you extend the throttle, it's going to use everything that you tell it to use. But it's constant, so you can count on it. We are basically using the 25 megabit second throttle at the Cassandra level. It's been working great. And the thing I mentioned earlier is that we don't use the SSL built-in feature. We have a virtual private network in between the actual data centers. Just showing you how constant it is. He's going to use that all the time, no matter what, to gossip. So what's the idea around it? It's basically having an API that can do everything, meaning compute, storage, network, backups, all the services we're providing, and be available everywhere. So everywhere in the US, everywhere in the UK, and everywhere in Asia with all the data there. Because when you're in Europe, you probably have some data center in America, right? So if you're in Europe and you have your footprint spread out on different continents, probably you want the same response time than on your UK footprint than on your US footprint. So typically that's what's happening. Is that if you remember like the overall architecture I showed you, it's on a per data center basis. So these APIs are actually available over there. So you can basically do a geolocalization, like Billy mentioned this morning, and basically redirect your users, if that zone is available, to those particular API. So I mentioned that we have one or two Cassandra racks on a per data center basis. Sometimes we have nodes that are dedicated for reads, especially the ones like serving APIs on a per zone basis. And this is why you would see them only being only used for read, while the other is basically write and reads for the actual aggregator and roll-up stuff. So let's take a look at, all right, so what was the pain point? Because globally, I have to say, we're super happy with the way things went. It's been working great, but so we had to couple of things that were like more complicated than others to configure. So for instance, the heap size and all the Java JVM setup, quite complicated. So you have a rule of thumb. Remember, I told you 32 gigabyte RAM for the nodes. They say 1/4 is a good start, but it doesn't always work like that. It might work on a regular basis, but if you need to run operation like repairs or like stream new nodes or like any kind of operation that's outside the normal, what the node normally does, you will have to actually like change the heap. At least this is what we found. Increase it to actually support those additional operations. That's been happening. It's not happening often, but that's something that's been happening to us. We're still using the CMS with Cassandra 2.1 right now. And we've been using like G1 for all the wildfly cluster. It's a dramatic improvement when it comes to GC poses. So we're really eager to try it with the latest version of Cassandra. And again, I think there's like a couple of rules to start with, but I think there's no magic bullet for that configuration. You basically have to test, monitor, and see what your application, how your application is performing, and then iterate on that. Some config options that will be really helpful is, of course, the concurrent write and concurrent reads. They're one of the causes for the Cassandra to go out of memory and crash if you go too crazy on that. The compactors, very interesting. I haven't checked the documentation for a while, but they were advertising very few compaction threads. Even with 10K SAS disk, we've been able to use, and we actually had to use in between 4 and 5 compaction threads. Otherwise, the compaction would get like really late, and the node would not perform, basically crashing out of memory at some point when you were like 1,000 compactions behind. The auto snapshot, be aware of that. It's enabled by default. If you have big tables, unless you have like twice the size of your actual disk, you may get bad surprises with like snapshot, like getting there and then beating you because you're not cleaning them up or not taking care of them. The batch size one threshold in kilobits is very interesting. This is something you want to monitor because it gives you an idea of the size of your batch statement. So when you start seeing like requests that are like putting too many, too large payload of requests, then it means that probably you want to go at the application level and see what kind of requests you do and what kind of inserts. Very, very insightful. And again, same conclusion as the other one. That plus the JVM is basically all the options that we had to play with and tune until we find something that was running well on our cloud. All right, so let's get back at Redis. So why do we have Redis, right? Well, Cassandra writes, no dupes, it's really great, and reads is good. And not good as like average, like really good. It's just like if you compare with writes, then it's a little bit under. So we're not storing a lot in Redis. We're storing basically bindings and common queries, like list of VMs to collect. Remember this binding in between like the series I showed you? This is something that we would, instead of like doing like queries, we would basically store some results and then invalidate that on a regular basis. So it's not really like, analytics data, it's more all the configuration and the correlation of those data that we basically like load in memory, refresh on a regular basis, but that really minimize a lot the queries that we have to do in Cassandra. And it's memory only, no, it's really transient data. It can be restarted, it doesn't matter. Migration, so this was a good one. So as I said, we were at the Cassandra Summit last year, and when the UDT got announced, we were like really waiting for it because, as you can imagine, we have all these services that are coming from third party, and it was really time-consuming to come up with tables every time, very specific, and have all these bindings, like 2-3 tables per service, etc. When the UDT actually came in, we started leveraging them like right away, and that really helped us like drastically to be really fast at integrating third-party services, and that was the main reason why we switched on 2.1. So we went live with 2.1.1. I think it was end of November, a good like 3 weeks before Christmas. Well, It was working great. We hit a couple of bugs, mostly at the driver level or on UDT. I mean, honestly, nothing really crazy to say about that release. But the big problem is that we had to retune the whole cluster. So all the settings that I actually showed you, when we switched to 2.1, we started to see nodes going out of memory. We started to see crashes. And that wasn't because necessarily that Cassandra was buggy. It's because when you do an upgrade like that, actually you have to go and retune everything that you had tuned before. And that was the most painful part of that migration. We use the Python driver for data upgrade. So I know they released a new version recently, but that was really slow for data migration. I haven't actually tested the latest. That's supposed to be much better in terms of performances, but we've been experiencing some very long migration time with the Python driver itself. All right, so what to not do at all at the application level? Secondary indexes. So we actually started using them, I guess, like everybody, when we initially lay out our model. Well, bad idea. As soon as you get a lot of data, that's not going to work. So you can still use it, but don't use it to rely on something that your application on a regular basis require. Use it for, you want to do some particular type of queries that are not planned. It's a one-time thing. Then, yeah, you put your secondary indexes, you run your query, and then you remove them. That works. The in operator, I don't really have data around it right now, but we are actually removing those in operators because we find them pretty slow at the moment on some tables that are pretty busy. So that's something that started happening, but I cannot say really more about that. The TTL, that was very interesting. So when we started, the idea was to grow the Cassandra node a lot so that we could actually make sure that Cassandra was handling the volumes of data we wanted. And at some point, we actually had to do some purge. The problem is that there's no range delete in Cassandra, so it makes that operation pretty slow, especially with the Python driver. So think about TTL up front, think how long are your data worth being kept, because it will avoid you having some issues later on. And of course, the complex relational type of model to not do, which brings us to the do's, which is basically designing very simple data model. Writes are cheap, duplicate data, and use basically batch statements to make sure that your model is consistent. But don't go crazy. The simplest model, that's what will perform the best with Cassandra. Minimize read from Cassandra a little bit if you're really read intensive. And the UDT are awesome. We really like them. Pain stuff, I'd say for us, the biggest one, that was bootstrapping new nodes. And remember, we started bootstrapping most of our data center in the 2.0, early 2.0 versions, and early 2.1. It's been really bad. I mean, we had to start and then stop and start and stop until having those tuning, those parameters and the nodes performing well, like I showed you earlier, has been complicated. So Cassandra 2.2, I haven't tried it, but they have a bootstrap resume that should address that problem, and I'm sure it's going to be really an awesome thing, because that was probably the most complicated thing that happened to us initially. Repairs are a big deal. It takes a lot of time. It hits your cluster. The incremental repairs, they're working now in Cassandra 2.1. They've been broken, I think, until 2.14 or 2.15. Major improvement, you can run them without hitting your cluster and without actually panning for resources on your nodes to support this operation on a regular basis. All right, so having said that, what are we thinking of doing? So as you saw, the JBoss cluster is really at the center of everything. It does all the rollups, the aggregation, etc. So we think that the problem we're having is not that it's not working, because it's actually working pretty great, but it's very hard to trace. We have very few visibility. We have hundreds of jobs, thousands of threads running. It's very hard for us to know exactly what's happening in it. And also we could go with a solution like New Relic and start putting information there and see how those trends. We believe that we might have some room for to introduce Spark and actually have Spark start to tackle a couple of these issues. But that's not the only reason. The only reason is because we want to start doing some more fancy stuff, namely around networking and pattern analysis, network analysis, pattern checks, etc., and introduce some machine learning on it and try to leverage the data we have. And as well, because our code base it's around 200K of Java, and that would be really good to start decrease that and get to a more smaller code base for the actual warehouse and platform. And the last thing, and I think there's a talk tomorrow, I definitely will be there, it's about compliance reasons. So it's very easy with Cassandra to replicate everywhere. It does it really well, it does it fast, super reliable. The problem is that sometimes you have some constraint when it comes to the actual data you're having, banking information, health information. And I think we will start looking at having multiple key space and see if we can actually have a subset of the data replicated or not, depending on the location and the compliance constraints we will have. There's a talk tomorrow, I don't remember at what time, but that certainly looks interesting. And of course, lowering the network traffic. If you replicate less everywhere, then you don't need as much network. Thank you very much, guys. I'd like to thank DataStax for the opportunity to present here. We're really happy to be here. And I'd like to thank my team. I have some ninjas over there developing and doing all that. And this is it's been really a great pleasure to build that up. So thank you very much.